If you're trying to produce traces out of your event-driven architecture, then this episode is for you. Welcome to Is It Observable? Today's episode is part of the OpenTelemetry series where we covered, in fact, lots of various episodes. Of course, we started with the introduction to OpenTelemetry. We looked at how to produce traces, what is the OPAMP protocol. We looked at the OpenTelemetry operator, how to observe your Kubernetes cluster using the OpenTelemetry collector, what is ADOT, and way more. Today's episode will be focused on producing telemetry data in a specific environment, the event-driven architecture. If you enjoyed today's content, don't forget to like and subscribe to the channel. So let's see what you're going to learn out of this episode. We'll start with an introduction explaining what is an event-driven architecture. We'll look at the various ways of producing traces out of our event-driven architecture. We'll look at in details on span links because we'll see that span links is going to be very useful specifically in the context of event-driven architecture. We'll look at also the various options that are offered by a couple of platforms like Solace that help us to host our brokers, our PubSub environments that is also able to produce extra details to our traces. We'll have a short interview with Tamimi, one of the DevRel of Solace, and as usual, we'll jump into a tutorial. First of all, you may ask yourself, what is an event-driven architecture? The objective of event-driven architecture is to create asynchronous tasks triggered by events. In most of the event-driven architecture, you will have always a producer creating an event, a broker that will store the event into specific topics, and a consumer that will get all the events of a given topic. The traditional API or HTTP request architecture is providing a different type of model. Due to the nature of HTTP requests, the services are waiting for a reply before they could process another task. In event-driven architecture, the flow is obviously different because each service is waiting for incoming message to start processing a task. For example, a phone call is considered to be synchronous, so more similar to HTTP request architecture. Someone calls, asks you questions to do something, so the requester is waiting while the responder complete the task. And then once everything is finished, then both parties is hanging up. In asynchronous example would be like a Twitter message, for example. You send a Twitter message and usually you don't even know who is reading our message. And moreover, we are not waiting for any response. But one Twitter message could generate lots of reaction that we may not even control. Most of the event-driven architecture utilize different protocols from the traditional synchronous applications. Synchronous applications are today mainly relying on HTTP, gRPC protocols. The event-driven architecture has different way of implementations. With a message broker, usually deployed as a backend component, we'll use specific protocols on the message broker. So the Kafka, for example, AMQP, MQT, GMS, Stomp, PubSub, and so on. Or you can also rely on a web messaging technology using technologies like WebSockets, PubSub, REST hooks, webhooks, and more. With our preferred observability standards, OpenTelemetry, you can now start building traces out of our applications. But you will see they are not a fixed rules when it comes to instrumenting our event-driven architecture. As we briefly explained in the episode Introduction to OpenTelemetry, a trace is a transaction that will have all the sub-steps of a given process that will be part of a transaction. Each sub-steps are spans. Do you know how OpenTelemetry is attaching all the spans into a given trace, even if we're using several technology or services? Well, To be able to attach all the spans into a single trace, OpenTelemetry is using a propagator. The propagator will inject the trace context when we're sending a request to another service. If I'm the first service of a given application, the trace context will be initialized by defining the trace ID and the span ID of a given steps. At that moment, the service A is calling another service, the service B. Then the trace context will be propagated in the request. In this example, propagation means injecting the trace context in the HTTP header. Then the service B will need to extract the trace context before doing any other task to continue the actual trace. So tracing event-driven architecture will mean that the trace context needs to be added in the structure of the message to continue the trace. In HTTP technology, adding the trace context is quite straightforward. We simply rely on HTTP headers. For event-driven architecture, there are no clear standards on how to set the trace context for all the messaging systems that we are dealing with. But each system is defining their own standards. So MQTT, the trace context, will be added in the message property. For AMQP, the trace context will be added in the application properties of the message. For Kafka, it adds the trace context in the header of the message. In S3 or object like PubSub, it adds an extra property in the objects or in the message. So if you're using a messaging systems not currently supported by the auto instrumentation library, then you will need to extend the create message or the receive message to extract the trace context out of the message or to create this trace context in your message. As you may know, OpenTelemetry is also structuring the information that will be held by our spans with the span kind. So at the moment you can have client server, but in the case of event-driven architecture, you have publisher, consumer, or process. So publisher for the publisher, consumers for the consumers, and process is maybe a task that is been generated from the consumer perspective. And then you have message attributes. So the messaging system, so which type of system we're dealing with, the messaging operations, publish, consume, and so on, the messaging batch, if with a number of message count, if the message is part of a batch, the client ID, the conversation ID, the messaging payload, the network protocol, the destination, the topic, and more. To instrument our event-driven architecture, we can rely on manual or auto-instrumentation libraries. If you're using auto-instrumentation library on a messaging system supported by our auto-instrumentation framework, we don't have to worry about adding our trace context to our message. It will be done automatically by the library. That is the case for Node.js AMQP, MQTT, GMS, for Java also, for AMQP, MQTT, GMS, for .NET as well. Then you have specific libraries for MQTT, AMQP for Go, Python, and more. Let's have a look at the Redis PubSub. In fact, in this specific technology, there are no metadata in the message structure. So you will need to add in the message the trace ID and the span ID to the message to add the trace context. So that means that you will need to extend the create message method and the receive message method to standardize the way you want to propagate your trace context in the message. Then, of course, you can also instrument your code using the manual instrumentation for most of the language. Of course, it will mean that the client SDK of the messaging systems is instrumented by the framework, and it will probably have a specific method to add or inject the trace context in your message, or of course, to retrieve the trace context from the message. So here is an example of a producer creating a message and adding the trace context in Python. As you can see, there's a specific methods to add the span ID and the trace ID. Here is an example of a consumer code in Python extracting the trace context out of the message. Once you have enabled tracing, you will be able to produce a global trace that includes the producer spans plus all the spans produced by all the various consumers. Depending on our systems, an end-to-end trace won't be very beneficial, simply because you will probably get a trace that is 2 to 5 minutes long, including all the details of all the consumers. Make sure that the generated trace is useful. Remember, you're going to use it to troubleshoot a production incident. So if you have a trace that is 5 minutes long, all the small steps of your transaction will be, of course, not visible anymore, so it will be very hard to utilize and be efficient to troubleshoot. If a trace is 2 or more minutes long, all your normal tasks that is normally taking less than 100 or less than 500 milliseconds, they are not going to be visible or very hard to see and to understand what's going on. That is the reason why we have other options to create our traces using span links. The purpose of span links is to simply link a trace to another trace. So in the example of an event-driven architecture, instead of attaching the spans of our consumers to our producer spans, we could use a span link. Span link will have the advantage to simplify the generated distributed trace. I mentioned previously how it is difficult to utilize a trace that is 2 to 5 minutes long. Well, span link will have the advantage of splitting each piece of a trace in individual traces. The producer will have its own trace and each consumer will have their own trace. To link all the traces of the consumer to our producer, we will create a link in each consumer trace. To create a link, a span link, as you understand, where the link will have the trace context, so the trace ID and the span ID of the initial trace, it means that we need the trace context of the parent. So in the case of event-driven architecture, you will still need to add the trace context of the producer in your message to let each consumer extract the trace context and build the span link. So here is an example of a Python code extracting the trace context and creating a span link. We can see from that code that we have the method start span takes a parameter allowing us to add a list of links. It means that we are able to attach several traces to a consumer. So the advantage of a span links is to create a dedicated trace for each main process of our transaction without, of course, losing any details or visibility. The major disadvantage of using span links is related to sampling. Because we're dealing with several traces, it's not guaranteed that the producer trace and or the consumer trace will be dropped. Therefore, it could happen that we have a link of a trace that is not being sent to our observability backend. The other disadvantage is that we're losing a bit the understanding of the relationship between producer and consumer. We don't link at the producer level, we only have them at the consumer level. If we want to understand how many consumers are related to a specific message or topic, we would need to extract first all the consumers' traces to then get all the links from the consumers to get to the origin, which is the producers. And then from there, you will be able to match the relationship. As you can understand, at the moment, we have the link from consumer to producer, but we don't have the opposite, which is producer to consumer. Out of the spans generated from the client SDK from our messaging technology, from the details from the producer or the consumer, you can also add extra details from the solution providing a managed version of our messaging platform, the broker. There is a solution called Solace, providing like a messaging mesh, providing you different type of brokers, MQTT, MQP, JMS, and of course PubSub, that is providing you a telemetry feature. Usually those solutions is also providing a mesh for our event-driven architecture, where we can mix several cloud providers in our architecture. The produced trace will help us to understand the time spent in the various layers of our event-driven architecture mesh. The concept is fairly simple. We create a telemetry queue in the messaging provider. This technical queue would need to subscribe to all the topics or all the queues where we would be interested to produce extra traces or spans from the platform. Every time a message is sent to one of the topics subscribed by this channel, the message is duplicated to our telemetry queue that will produce spans once the message is received. Of course, this is only working if you are propagating the trace context using the library from the platform vendor, Solace, for example. Because at the end, it will produce traces if the system is able to detect the trace context. So it means you make sure that the trace context is set properly and respecting the vendor's platform. In the case of Solace, the client SDK will automatically add the trace context in the expected format for most of the language. So they provide you to an auto-instrumentation library supported by Solace. But of course, they also provide a manual way of creating your spans. The question that you may have is, how can I retrieve spans produced by this platform from Solace? Well, fairly easy. Solace has added in the OpenTelemetry Collector contrib repo a specific receiver for Solace. In this receiver, you will precise how to connect to your telemetry queue. For example, here is an example of a configuration where I precise the URL of the broker, the authentication, with which user I want to use, the password, which queue I will connect to get the spans produced by Solace. So our collector will have our producer, consumer spans, plus the one coming from the messaging platform. With the spans created by Solace, we can now measure the network latency between the client producing and publishing the message and the message actually received by the platform Solace. In order to get more details on the telemetry data produced from the messaging platform, let's call Tamimi DevRel at Solace. Hi Tamimi, how are you?
Hi there, Henrik. How are you? Thanks for having me today.
I'm very good. In fact, I'm currently working on an episode related to tracing on event-driven architecture. I explain various ways of sending traces, especially related to how we can add the trace context into our message. I also explain the value of using span links. And last, I have briefly introduced the feature that Solace is providing related to distributed tracing, where Solace is adding extra details from the messaging platform. So I have tons of questions related to Solace supports of telemetry data. But before we start, could you introduce yourself to the community?
So my name is Tamimi. I'm a developer advocate at Solace, located in Vancouver, Canada. And I'm involved with all things developer enablement within Solace.
Some of us are probably not familiar with Solace. Could you remind us what is Solace? What is the advantage of a platform like Solace?
Yeah, so in a nutshell, Solace provides a platform for organizations and enterprises to become more real-time and event-driven. We do this through providing a design time and runtime pieces for the event-driven development, and through an event portal to help organizations design their event-driven architecture. And we have an event broker, which is used in the runtime aspect to use for like a lot of different use cases, operational use cases for event-driven development. We provide a lot of things and support high throughput, low latency use cases. And as time progresses, we constantly keep adding new features and improving the already existing features within the Solace broker. So pretty much for use cases that requires event-driven development and real-time development.
I also heard from a couple of customers that Solace is also providing an event mesh. Could you remind us what is an event mesh? What's the value of using an event mesh?
An event mesh, basically, in a nutshell, is a network of interconnected message brokers connected together and being able to transfer data throughout the different brokers. So the different use cases that we have for an event mesh is if you have different geographical locations and you want to move data across multiple environments or between cloud and ground, and if you have kind of like a hybrid use case, that usually also helps. And another key advantage for the Solace brokers or the event mesh, it is cloud agnostic. So you can deploy the event broker on different cloud providers and be able to move data through different cloud providers and between different microservices over the event mesh. We do this in a dynamic fashion. And because one of the other key advantages for using Solace Broker is we are protocol agnostic. So you can have different protocols and we'll have the protocol translation, the language translation directly and natively within the Solace Broker. So you can picture this having a polyglot of microservices with different messaging protocols all connected to a mesh of Solace brokers interacting together, whether they're on different cloud providers or on-premise as well.
So by creating traces out of the messaging systems, I noticed that there are several client SDK that are supporting out-of-the-box auto-instrumentation on most of the messaging platform. But for few language, it has a limited support. It could be very useful for us that you remind us the various support of event-driven instrumentation, automatic instrumentation, or in the other way, using only the manual instrumentation.
So for the folks who are already aware about OpenTelemetry, distributed tracing in general, or they're just starting to get into the OpenTelemetry community, you would be aware that OpenTelemetry provides ways to instrument your overall system. So if we stand back and look at it from a higher view into this, you could look at it as you have two ways to instrument your system, either through auto instrumentation or manual instrumentation. With auto instrumentation, OpenTelemetry provides the OpenTelemetry agent that you can deploy as on the side to your applications, and it would inject trace information to any of the messages or interactions in your microservices without changing any code in your microservices. And this is where the auto instrumentation piece comes in. If you check out the OpenTelemetry website and look at the auto instrumentations section, you would see a bunch of different languages that supports auto instrumentation. So for example, Java being one of the most popular ways of auto instrumenting your system, you could run an OpenTelemetry agent on the side, have custom extensions that would intercept the messages or kind of understands what are the protocols, the communication protocol within your microservices, and then inject trace information. So from a Solace perspective, we have taken the path of auto-instrumenting Java applications using JMS as a messaging protocol, where you could spin up your OpenTelemetry agent, attach the Solace extension to the OpenTelemetry agent, and then have your Java applications that are communicating with the Solace broker already running, and then the OpenTelemetry agent will be injecting trace messages and trace information pretty much and context throughout the messages until it is being received at the Solace broker. One of the advantages for this is you don't need to make any changes in your code, and now trace messages and the context is being injected in the information that is being passed into the Solace broker. Now, one of the things when it comes to tracing in EDA in general, you can add trace information on the API level, application level, and the broker level. What Solace is adding, and the key competitive advantage that we're bringing into the space, is adding traces within the broker. So figuring out what queues the messages went to, if there's acknowledgements or nags that happened in your messages, whether the message was sent to your end client, if there's dead letter queues. So all this kind of information within the black box of the broker, we are exposing it through generating traces. To answer your questions regarding auto instrumentation and manual instrumentation, right now we have the auto instrumentation with Java, and because Solace has a lot of different APIs and languages, we're slowly rolling out manual instrumentation support for every language. So we have Java up, Next, we have coming our new generation Java, Python, and Go, and the rest of our APIs will also be getting this updated support for manual instrumentation within the code itself.
So you mentioned an extension that you attach to Java for JMS protocol. For example, if I'm using Java code with AMQP or MQTT, does Solace provide also an extensions for AMQP and MQTT, or is it only currently limited to JMS?
So right now it's currently mainly for JMS, and the extension, what it does is it injects the trace context to an SMF message. An SMF is a Solace message format that is proprietary to Solace, and we are injecting information there. If you're using an open standard messaging protocol, then you can inject information within the protocol itself. But when you communicate with the Solace broker using the Solace message format, SMF, you can use the Solace APIs to inject trace context and trace information in the message when you send it, before you send it to the Solace broker.
Which means if I'm using something other than JMS, it means that I will need to use your current client API to add the trace context. So then you're able to extract and identify the trace context out of the message.
Correct. And as I mentioned earlier, since we are doing continuous development and R&D on distributed tracing within the Solace broker, we will be looking into seeing how we could have interoperability between different protocols within the Solace broker when it comes to a distributed tracing perspective. How do we make sure that there is a common way to propagate the trace and context? And I want to point out as well that the OpenTelemetry community in the messaging space, they're still in the process of standardizing how messaging and distributed tracing works together. So we are working hand in hand with the OpenTelemetry community. We're joining their meetings on a regular basis as well to see how we can standardize messaging and distributed tracing. Distributed tracing, or just like observability within the messaging space, is still getting a lot of development, and we are kind of trying to stay up to date with all the changes that are happening, with all the things that are going. So you can see that there's always changes that are happening, because we don't have a lot of standardization in the space and the community itself.
Yes, when I prepared the episode, I looked at the OpenTelemetry specification. I think that the semantic conventions are really clear, very well defined, and very well structured. But when it comes to passing the trace context, it's a bit blurry, because every protocol is sending the trace context in the message in various ways, through the header, through the message property, from the property of the message, and more. I think it would be great to standardize everything, especially how we need to pass the trace context within our message.
Exactly, yeah. And we truly understand that if you're working with messaging and event-driven development, you're using different technologies, different protocols, different vendors, and you want to make sure that there's a standardized way. And OpenTelemetry, when they first started, they wanted to make sure that there's a standardized way for communicating traces. So when you look at the OpenTelemetry collector, there's a standardized way, and any vendor or any protocol, they want to make sure that they communicate the same language. And now they're trying to bring the standardization to messaging.
So you mentioned that Solace is providing a feature that allows us to get details from the broker. So when I looked at it, I really like the fact that we are getting the extra details related to when the message has been actually received from the broker, so we can start measuring the network latency between the producer and the broker. Are you planning to add more details, especially related to the usage of an event mesh?
Right, 100%. So since I mentioned earlier as well, this kind of work in progress, we're adding more information within the broker that can be generated as what happens to the message within the broker. And if you can also imagine how if you have an event mesh use case and scenario where you have multiple brokers geographically located at different parts of the world, and you're sending a message from one part and it's propagating through the mesh, you want to know what happens inside the broker. So whether it goes to a dead message queue, whether there's a timeout, if there's a message there was a timeout in the message and it moves to the message queue, or you've lost the message. And then at the end of the day, you ask yourself, the consumer never really received the message. What happened? So you look at an observability backend to see the journey of the message, and you can say like, okay, it went to this broker, but then when it arrived to this broker, the queue was full. Or it's waited for a consumer to receive the message, and then the time to live expired. So all this information will be shown within the generated traces. And now we've added more support on to say like, okay, the message has been received by the consumer and the consumer acknowledged the message. So now the Solace broker will generate trace messages and will generate spans to show that, okay, this is what happened to the message. So now you're drawing a clearer picture and a more detailed picture on what happens to the message inside the broker. This is the keyword, is like what happens inside the broker itself, because there's so many different things that could happen within the broker.
We've been mainly discussing about traces, but it would be great to also have metrics generated or even logs from the broker. Are you planning to extend the other type of signals that Solace is able to produce on the telemetry profile?
Mm-hmm. So now we do have another product within Solace. It's called PubSub Plus Insights, that generates information about the underlying what's happening within the brokers itself. So we generate metrics and logs within the broker. But when it comes to the message that is being transferred throughout the journey of the message, we started focusing on distributed tracing, and we were like, all right, we're going to generate information about what happens with the trace of the message, and then we will continue to be adding more supported details. But I would definitely suggest and recommend, if anybody is interested, to look more into what kind of log data we can extract or we can export from Solace. There's the PubSub Plus Insights that kind of shows all the different information on what happens within the broker itself and within the mesh in general.
Awesome, that's wonderful. So where can our community get more news about the telemetry support of Solace?
I think right now the best way to get the information about the distributed tracing within Solace and the PubSub Plus event broker is through joining the Solace community at solace.community. But we're constantly trying to post information and updates through blogs on different blog sites, blogs on the Solace site. If we're attending conferences, so stay tuned. Like keep an eye open to what conferences we're attending at solace.com/events. Feel free to meet us at the conferences where we give updates about these kind of things. We're planning to give talks as well about distributed tracing in event-driven architecture in general, but mainly we would start with the updates on the Solace community, where we also release early access information. So if somebody wants to have early access to a particular feature, we would release it on the Solace community, and we'll work hand in hand there. So that's we start from there and then branch out to other forms or platforms of updates.
So I think I've covered most of the questions that I had. So thanks a lot for your times, and a big applause for the team to work on adding extra details to our telemetry data. That is just wonderful. Thanks.
Fantastic. Thanks.
You're welcome. Thanks. See you. In this tutorial, we'll show the difference of producing end-to-end trace from an event-driven architecture versus using span links. We will use Solace PubSub as our broker platform. We'll configure the telemetry queue to collect traces from Solace, also, and configure the open telemetry collector to collect the spans generated by Solace. All the produced traces will be sent to Dynatrace. So it means that for this tutorial, we'll need different things. We will need, of course, a Kubernetes cluster, a Solace account. So if you don't have it, you can start a trial, the open telemetry operator to deploy our collector, a demo app producing and consuming messages, and of course, a Dynatrace tenant. Like every tutorials that we delivered at Is It Observable, there is always a GitHub repository. And here we're looking at the repository relating to event-driven tracing as expected. So a couple of things like I mentioned, I will let you build your cluster. So in my case, I'm using GCP, but you're free to use your own cluster of your choice. Next thing, like I mentioned, there are a few things that is required. The first thing is you need to have a Dynatrace tenant. If you don't, you can click on Dynatrace trial, and it will provide you a new cluster, new tenant, sorry. And you will just have to provide your email address and you will get your new tenant. So that's the first thing. Second thing is we're also relying on Solace because the PubSub and the broker that we're going to use is going to be Solace. So if you don't have any Solace account, which could happen for sure, make sure to try like a trial at Solace. So a PubSub for free. And you will be able to at least generate some traces. The only limitation that I would say is that everything related to the telemetry profile that I'm going to cover today requires a license. So you're probably going to be able to touch that, but at least you will have the trace spans produced by the producer and the consumer. Now, once you have that, there are requirements from a Dynatrace perspective, and there are requirements from a Solace perspective. So let's cover those requirements. So first, in Dynatrace, once you have your tenant, even if you have a new generation of tenant, you will have to go to access token, which is on the left menu here, and you will have to create a new access token. So I already have generated it on my end, so I won't do it again. But to remind, because we're going to ingest traces, type ingest here. And here in this particular tutorials, we only cover traces. You can basically only select that OpenTelemetry trace scope, but we could have extended to logs, events, and metrics as well. So once the tenant has been, once you have selected the scope, you will create. The value of the token will be displayed once, so make sure to copy it because you will need it later for the deployment script. Second thing which is required is the tenant name. So you can see that here in the top of your browser, there is your URL. Make sure to copy everything https://until.com. So that will be the Dynatrace tenant URL because you will need it for our script. So that's the thing from the Dynatrace perspective. Now, let's look at Solace. Solace, we need a few things. So once you have started your trial with Solace, there are a few menus here. You can see you will have to go to connect. And you can see that it provides different type of protocol support, which is awesome. And in our case, we are using the PubSub and using the standard Solace messaging. So if I expand that, you will see that I have some couple of information available. I have the SMF host. So you make sure to copy the entire URL. You need the message VPN. Make sure to copy that. The password and the username. So those are the 4 fields required to let our producer in one hand producing messaging to that PubSub, and on the other hand, on the consumer, we need also those authentication details. So make sure to copy that. Save those 3 elements into those variables because we will need them to run our deployment script. Then there is one thing which is important. I already have imported my certificate, so it works with my variable. But in your case, you can see here there's download PEM. This needs to be downloaded and put it into repo. So make sure to clone the repo. This is very important. And as I'm going to show you here in the source directory here, in my case, I have my certificate, which is here. You will have to copy paste it on all those 3 folders, and because it needs to be embedded in the container. And then in the Docker file, you can see here I'm copying it to the Trust certificate store. So you will have to rebuild the container, publish it in Docker Hub, and if you do that, very important aspect is that now when you deploy this tutorial, which is going to be done automatically by the script, you will need to modify the deployment manifest file. So if you go to manifest here, there's some deployment files. And as you can see, there is specifically here, you can see that I'm using a reference to my own publisher and my own consumer. So you will have to update those 2 with your own container that you have built from your own side using your own certificate. All right, make sure, so to remind, download the certificates, put it on each folders of each pieces of code, consumer, producer, and so on. And this certificate will be required because we will need it to authorize the consumer and the producers to publish into our PubSub on Solace. All right. Next is if you follow this repo, there are a few things that we're going to define specifically on the telemetry. So to be able to do that, you will click on Managed, and in Managed there is Message VPN. So let's click on Message VPN. And that will provide you to the settings of your VPN messaging. And as you can see, there is in the messaging VPN, there is a section called telemetry. And here in telemetry, first you will have to enable it. So as you see, it's licensed. So if you don't have any license, you won't be able to run that scenario, but don't worry, you can still follow. You will give a name. So here, and this name will automatically build by default a queue. That having the same name, so telemetry, Solace, telemetry in my case, because I named it Solace telemetry. And this is going to be used, and then you will have a client profile. So then, of course, you will have to configure the receiver connect ACLs to be allowed. So you're allowing traffic to go in. You also enable the trace and the receiver. So those are the two things you need to do. And the trace filter will be set to default for sure. So if you click on default, then you can see it's enabled, and you will have to define subscriptions. In my case, I have defined this. If you follow the steps, it will basically add all the messaging for on the queue to this telemetry queue. So that's from the queue perspective. Then if you go to access control, we need obviously to have an account. So here in my case, if you go to access token here, you can see that I have a client profile here, and I have created here a username, so a client username, sorry, and I named it Trace, but you can name it as you want. You will have to set a password, and then you will attach this to a client profile called telemetry, which is the one that corresponds to our queue, and of course you will. That's pretty much the only thing that you need to do, and of course define a password. Then the client profile, you can see that we have the telemetry Solace telemetry, which is here. So make sure it's enabled, that you're able to use it. But usually you don't have to configure much. So that's pretty much for this. And then in terms of queue, you can see here, we have the queue here available. And this is the queue that will be used to collect our traces. So once we have this, we don't have to add any specific subscription. It comes along with the configuration that we did previously with the queue and the users, but that's about it. One thing which is important, once you have that, you need to figure out the settings to connect to that queue. So first, you remember we created a user. In my case, it was client user equal trace. Then there's a password for that. So keep this password on the side. You have the queue name. So that's the queue name that you're going to use. And last, you need the settings to connect to that queue. So if you go back to Solace administration platform, you have connect. If you go to connect, we can go back here and select specifically the IMQP protocol, so expand it. And then from here, you will see that you have also URL here for MQP. So you don't need to use the IMQPS and so on. You just select everything after MQPS. That would be your MQP connection details to reach out to that queue. Don't worry about the username and the password. We don't need because we already created one. So that's what you need. At the end, you will have to store your telemetry IMQP URL, the telemetry queue name, the telemetry user, and password. So those are the three things that will be required to configure our OpenTelemetry pipeline. Once you have all those variables populated, you can run the script and that will deploy everything. So what are you getting out of this? So first, if you look at the namespaces that we have here, see that we have a couple of namespaces. So cert manager, because we've deployed the OpenTelemetry operator that requires the cert manager. And then we have the EDA namespace and the default namespace. Those are the two main that will be basically configured by the script. So if you look at the EDA, the pods running in the EDA namespace, you can see that we have a consumer, two consumers, database and rest. And then we have like a job that runs every minute, which is the producer. So every minute it will produce a message to the queue. And the others are basically pulling every X minutes, every X seconds messaging from the queue. So that's from the EDA. Now, if you look at the pods running in the default namespace, that will be our collector. So our collector is deployed as a daemon set. So that's why we have two collectors. And this is required because that will make the bridge to Dynatrace. So if I go to the source code, I will have, there's several files, don't worry, because I already have prepared without span links and with span links. But the publisher, it's going to be the same code. There is no difference without or with span links. So if you look at, pay attention to this code here, it's using the Solace a client API and the OpenTelemetry SDK, both. So here it's going to be built through manual instrumentation. What we can, like expected, we define the trace provider, the exporter, the batch processor, and so on. Then you can see here we start the spans here. So we have a main trace, and then we have this current span. And you can see that later on, we are sending a message, and this is where we define the message. So here, the send message span, you can see we are extracting from this specific span the trace ID. We are extracting from this span the span ID we just displayed for fun. And last, we are creating the message. The message is very simple. Just add some text, nothing fancy. But what is important is I'm using from the Solace Python library the method with trace ID and with span ID. So this is making sure that we are adding at the right level or the right property or whatever it is those information. So then the telemetry feature provided by Solace will be able to extract the trace context. On the consumer level, similar thing. So here it's the first example is basically an end-to-end trace. So the first thing that I'm doing in this consumer code, I'm not going to show both, but one is enough. We can see that here the first thing that I'm doing here is from the message that I received, I'm extracting. So there's another method for that. A message get span ID and trace ID. You will have to convert it from bytes to integer. Once you have that, then you can create your span context with the help of that, and then set your context. So then the next spans created will follow and the trace will continue from the publisher to the consumer. I have first in one end the collector. So the collector here is receiving metrics and traces, but at the end we are just covering traces, to be honest. So one thing is, you can see I'm using the OpenTelemetry collector CRDs to deploy I have a couple of secrets where I store the Dynatrace token, the URL, and the various settings to connect to Solace. Remember, we defined the telemetry queue. And here you can see that it's using one of the receiver available from the hotel contrib repo called Solace. And here I'm configuring how where is located the broker. So here it's the URL of AMQP. And then the authentication here is using the user and password that we just created. And we're looking at the queue that is being created with the telemetry queue. So that's required. Of course, I'm receiving OTLP for the rest of the traces, publisher and consumers. And as you can see, the trace pipeline takes OTLP and Solace and is exporting it to OTLP HTTP, which is where the destination where I'm going to send the trace, which is Dynatrace. If you look at Dynatrace, if you go to application and microservices, you go to services, you will see that we have, in my case, 4 services, one for the publisher and one for the consumer REST, consumer database, and the other one is the technical queue that is coming with the Solace telemetry support. So let's look at the publisher. Because the publisher is, you have a span kind publisher, I will look here on distribute traces to see the traces generated from this service. So if you look at that trace here, you can see that we have the publisher spans, and then we have all the other spans related to the consumer. So connect to PubSub, send the message that we saw in the code a few minutes ago. And if we pay attention here, you can see that we have the receive. Receive is the one coming from the telemetry profile that we have generated. And then, of course, you can see that's an end-to-end trace. So we have the trace from the consumer RESTs doing some stuff. And then we have the trace for the consumer database where we have some stuff. So at the end, we have a trace that is almost 3 minutes long, very long. So the long bar, we see it quite well what's going on. So I can click and that's perfect. But if I look at this one, which is a couple of milliseconds long, by the way, there's a lot of interesting span attributes added by Solace, so I would definitely request to store it because it makes sense to get the dropped application message property, the enqueue, and so on. So that there is a lot of interesting things. So I will definitely keep it. But one thing is, you can see here, even the send message, if we look at it, it's very hard to understand what's going on. So you see here, it's a couple of 100 milliseconds and so on. But because it's the size of the trace make it not visible. To use the span links, the only thing that we need to do is to change our consumers. So if we go back to our code, if you look at this file, consumer_database, it's the first piece is the same. So I start with getting the trace ID and getting the span ID. So this is not changing at all. Then I create a span context with the trace context that we have just built, coming from the trace ID and the span ID. And then I'm starting an array called links context. And I'm adding to that a link. So it's going to be a span links with the context that we coming from the producer. And as you can see, the method start span here at the end takes an array of links. So you can add several links. So that's the only change that we did from the previous code. Nothing fancy. So if you want to build it by yourself, make sure to change the Docker files to use this file, rebuild it, and then do the same for the rest. So in my case, I already done it. It's the 02. So I just need to, publisher will be the same, but I will modify. The rest is going to be the version 02. And the database as well. So now I've done those changes, and now I just need to redeploy. So I'm going to use kubectl. You can go back to services, and we're going to select, of course, because the change will happen at the consumer level. So now we have this trace, write, update, rest, receive from the consumer REST. So this is a few minutes ago. So now we have only, you can see the consumer REST here, and you can see there is a link here. So now if I go back to this link, it means I can click on it, and that will bring me to the trace coming from the publisher. So you can see that I have only, it's first of all, from the publisher level, it's easier to consume it, to see the actual details. So you can see that the links were available at the consumer, and I was able to get back to the producer.
That's it for today's episode related to event-driven architecture tracing. As you saw, there is no clear standard on how to propagate the trace context on the various messaging systems of the market. Before you start, as a recommendation, I will say, look at the auto instrumentation library that are available on the market to look at if your messaging protocol is supported and if the trace context will be added automatically. In that case, no major effort. If you're relying on a messaging technology where you don't have any auto instrumentation library available, then I would recommend to create your own message methods to add your trace context, and same thing for the receive message to extract the trace context out of your message. If you rely on a messaging system platform that is providing telemetry data like Solace, make sure to add it, because I think it's still useful to get this extra details on the network, where how long it took to be received at the broker level, and if you have a mesh, how long it took to be forwarded on the various queues of the architecture. So if you like this episode and you enjoyed this video, don't forget to like and subscribe to the channel. So see you soon for another episode.